Hi, good morning all. Welcome. We're just going to wait for another minute to let a few more people in through the lobby. Cool. Okay. Welcome to another spring showcase. We're excited to present showcase number 33. In this session, we will be hearing from United Utilities, the lead water company on the Water Printrastructure Project, otherwise known as WIP, alongside project partners Changemaker 3D, Manchester Metropolitan University's PrintCity and Scottish Water. This innovation project is supported by Ofwat's Water Breakthrough Challenge and is on track for completion in early 2025. For those who may not be familiar with Spring, the Spring is the Innovation Centre of Excellence for the UK and Ireland water sector. Our mission is to centralise intelligence on existing water innovations, foster collaboration, eliminate duplication and accelerate progress within the industry. Spring also issues calls for innovation aligned with key themes of the Water Innovation Strategy 2050 through the Spring Accelerator program. Currently, we're running Spring Accelerator 4, focusing on emerging contaminants, and Spring Accelerator 5, which will address the topic area of leakages and bursts. Applications for Essay 4 are now closed, but don't worry, applications for Essay 5 will be opening soon. To stay updated with these programs, please follow our LinkedIn page. However, today's focus is on knowledge sharing. Apologies, the clicker is not working. There we go. I'd like to briefly explain to you why we organise these sessions before we jump into today's Printfrastructure showcase. The water sector is currently facing significant scrutiny, which highlights the urgent need to accelerate collective problem solving. Knowledge sharing plays a pivotal role in helping us achieve that. Over the past 6 months, Spring has partnered with Ofwat, the economic regulator for England and Wales, to develop a set of vision and set principles of best practice knowledge sharing. Senior leaders and innovation managers were brought together to collectively design this vision and define what we aim to achieve. Last week, Spring partnered with Ofwat to host an interactive workshop on best practice knowledge sharing vision and principles. If you missed this or are interested in watching the recording, the link will be shared in the chat. And this is based on the PowerPoint slide that is currently up on the deck, where you can explore those 6 principles and vision further. Bringing it back to today, thank you all for joining us. We're delighted to welcome representatives from 13 water companies across the UK and Ireland, as well as a few international audience members. A warm welcome to the WIP showcase and thank you again for being here. At the end of the showcase, we'll share a poll to gather your feedback on how engaging you found the information and whether you plan on applying it moving forward. Please take a moment to submit your responses when the poll becomes available. You'll also have the opportunity to ask the project team questions during the Q&A session at the end. Feel free to share your questions in the chat throughout today's presentation. If you have a question for a specific speaker, please include their name. On to today's session, I'm going to run you through the agenda and introduce our speakers before I hand you over to Lisa. Okay. So, firstly, we'll be doing an introduction to United Utilities and the Ofwat competition. And then we will highlight the importance of knowledge sharing before moving on to Work Package 1, which is all around concrete printing, before moving on to Work Package 2, which is around polymer printing. Then we'll go on to a short break, and when we return from the break, we'll have a reflection on the water industry, and then we will move into the Q&A portion of the showcase. If we wouldn't mind having microphones and cameras muted, please, for the presentation, that would be great. Thank you. So today we will be hearing from Lisa Mansell, Chief Engineer of Innovation and Carbon at United Utilities. We'll also be hearing from Richard Clark, Program Manager at United Utilities. Then we will also have Natalie Wadley covering Work Package 1, Co-founder and CEO of Changemaker 3D. Then we'll move on to Alan Dempsey, who will be sharing a video recording today, and he is Project Manager at PrintCity, Manchester Metropolitan University. And then last but not least, we will hear from Ian Watt, Capital Investment Net Zero Manager at Scottish Water. Thank you all, and I hope you enjoy today's session. I'd like to hand you over to Lisa.
Thank you very much. So hi I'm Lisa Mansell, Chief Engineer for Innovation and Carbon at United Utilities, and it's my team that has been working on the Water Industry Printfrastructure Project that you're going to hear about today. We're an engineering innovation team within United Utilities. We work very closely with our central innovation team, delivering engineering innovation projects, but we have a real focus on how do we adopt those within our capital programme, as that's where our engineering function sits at United Utilities. So we just wanted to give you a quick overview of the Ofwat innovation competition. It's a £200 million innovation fund for water companies in England and Wales, and it's set to kind of grow our innovation capability and really help us with the challenges that we have that we're facing into as we move forward in our investment programmes. The fund is £200 million for AMP7, but actually will grow for AMP8, and really kind of as a water company that's led on projects in the competition and supported other water companies with their projects. It's a really exciting space to be in, and we're really delivering much more complex and greater value innovation projects than we've ever delivered before, and we're really valuing the Ofwat Innovation Fund at the moment. There's two streams. There's a catalyst and a transform stream. There's actually a discovery stream as well, where suppliers can lead on innovation ideas, but for the catalyst and the transform streams, water companies must be the lead partner. And there's some things to think about in terms of the Ofwat innovation competition, just if you're thinking of applying, they have to be collaborative in nature, the projects. The idea is that water companies come together and address challenges together and run projects that they can work on for the sector and share all that knowledge, just in the way that we talked about knowledge principles earlier. The results must be made available to the rest of the sector, and we're really trying hard to share what we can throughout the project, and that's why we're here today. We haven't actually finished the Water Industry Printfrastructure Project, but we're trying to share a kind of a midpoint within the project, the progress that we've made, and for you to be able to capture and utilise that learning today. And you kind of just something to think about if you are looking to put a project into the competition, is you need to, the projects are 90% funded by the competition, and the remaining 10% must be found within the project partnership. So thank you very much to our project partners that are here today, Changemaker 3D, Manchester Metropolitan University and Scottish Water, because we were able to come together and pull that 10% together to be able to run this project. Just as the kind of lead water company, I just wanted, at United Utilities, just wanted to share a little bit about us as a company. We're a large water and wastewater provider for the northwest of England, and we're working in a very challenging regulatory sector. We've got a huge capital programme that we're facing into, and we need solutions that can help us deliver on that. We have 575 wastewater treatment works and 96 water treatment works, and all of those assets need maintaining, and we'll hear a little bit today around kind of how 3D printing can help us with that challenge as well. We have a great open innovation model, and we really source ideas from everywhere, internally and externally, and we really kind of encourage people to bring forward their ideas, and we'd love to progress those. And two examples that you'll hear about today have come through our innovation lab in the case of Changemaker 3D, and through working on our graduate CEO challenge we run internally at United Utilities to really kind of develop ideas in our newest staff. So both of the ideas you'll hear today have come through some of those different methods that we've got at United Utilities that really help us to source new ideas and progress them forward, and then we've developed them into this really exciting Ofwat Innovation Fund project. And then finally, just a kind of around open innovation, how that brings benefits. We talked earlier around kind of we've been finding and persuading people to bring forward their ideas, and we've done that through some different methods. And we like to broker it and test these things, and you'll hear around kind of how we've been de-risking these solutions for the sector. And very much focus of the water industry Printfrastructure is how we can adopt these solutions, and you'll hear today how we're pushing these into operational environments, and that was the main purpose of this project. And sharing and endorsing, that's exactly why we're here today, to provide this knowledge share to the sector and to other sectors too, and to really showcase how we've driven this kind of 3D printing attitude, and this mindset of can we do things differently, can we build and maintain things differently for United Utilities and for all the partners and all of our cross-sector collaboration. I'm going to hand over to Richard now, I think, to introduce the project properly.
I'm Richard Clark. I'm Programme Manager for Engineering Innovation here at United Utilities. And well, the story around Water Industry Printfrastructure, or WIP for short, started for me around 4 years ago now, when Changemaker 3D came to us through the Innovation Lab, which focuses on helping SMEs come into the water industry and understand how their technology can work with us within the water industry, but also understand how they work within the water industry as well, the things that they need to do to really get a foothold within our industry. So that's where it started for us. Changemaker 3D came to us with the idea of 3D concrete printing, and we took that a bit further and said, well, what does that mean? Okay, how will that work? So we printed the first water retaining structure. Okay, we printed a tank in that first phase of 3D printing, and that worked for us. We saw something in that we could take further. And just around the same time as that happened, Manchester Metropolitan University came on with their PrintCity function, and they said to us, well, have you thought about 3D plastics printing and what we could do within your industry with that? So we thought, okay, that's an interesting concept as well. So we started talking to them about the possibilities. And just as that happened, the Ofwat competition that Lisa's just mentioned came along. So we had a funding mechanism. We were able to go out to the wider industry and start understanding how we'd fund a project for yourselves, and how we could look to see how this could be taken up across plastic printing or concrete printing across the water industry. And as we were forming that proposal, Scottish Water joined us and realised that the things that we were talking about, things that we were wanting to do within that proposal, aligns to what they were being asked to achieve with regards to net zero through the Scottish Government. So it all lined up nicely, and that's how our collaboration, our partnership came together. Good. There we go. So on to the next slide. So what we're trying to do, why our proposal was successful. Well, we're looking at new ways of working. We know that going forward into AMP8, there's going to be more work for us to do across the water industry. There's going to be more pull on our traditional resources. So whether we look talking about mechanical engineering, electrical engineering, civil engineering and process, we know we have those traditional mindsets, those traditional disciplines to help us achieve what's a much larger challenge for us going forward over the next 5 to 10 years. But this really does, this 3D printing approach, helps us add more to that, helps us enhance that, moves us forward, bringing new skills into our industry. So whether it's computer modelling, whether it's actually operating 3D printing systems, they're all things that we can add on and enhance what we do across the industry and help us achieve that much larger challenge. So we're looking at how we do that. We're looking at new materials as well, how we go about using alternative forms of mortar and concrete in our 3D printing activities and concrete printing activities. We're also looking at how we use different types of plastics within our 3D plastic printing. And it's about how we not just look at our infrastructure and how we're going to help our capital programme deliver, it's also about our operational functions as well. Are there things we can do to help our operators out on our existing water and wastewater sites? How can we help how we're helping our technicians within our laboratories as well in what we're doing with them? Are there things we can be printing for them? to make our lives more straightforward, making it a more efficient delivery across our whole sector. Our project was broken down into 2 work packages. So we have work package 1, our 3D concrete printing package, and this is what we did at Wigan. And some of you were lucky enough to come along to see us at the end of May, early June this year, to take a look at our hub, our printing hub at Wigan Wastewater Treatment Works, where we had a couple of weeks where we printed a whole range of different items, which Natalie will take you through in a little while. We also moved our robot over to Weaverham Wastewater Treatment Works to see what it was like to actually print in situ on the works. So move a robot into place, see what kind of challenges came about through printing in situ. In work package 2, we looked at the 3D plastic printing. So PrintCity helped us understand what we could do from printing existing items or bespoke design items, and see how we could use the 3D plastics printing technology across our whole business. And that came up with a few really good examples where we can massively reduce carbon in the things that we do, but also how we can make bespoke items for ourselves that really do achieve what we need through our operational resources. Just staying with 3D concrete printing for a second. So there were a few decisions we needed to make on the way. Okay, so it was a case of just to fit our project and what work within our thresholds. We needed to decide what it was we wanted to do. There were some options open to us, one of which was the type of robot we could use. So we were able to look at gantry robots, which would suit us if we were staying in one place for a very long time, and we were printing a whole host of items in that place. However, the gantry robot is hard to move around between sites. And we wanted that flexibility. So we went with the robot option, the tracked robot option. So that meant that we could move between sites and be able to see what the impact was of different operational conditions. Another thing we needed to think about was whether we wanted to use a print hub model or whether we were looking at an in situ model. So when we talk about a print hub, we talk about maybe a temporary building. So in our case, we actually used a temporary tent. It was a posh tent, a big posh tent, or if there was a bit spare building available on our site. We looked at that model where we could print a whole host of different items, not just for ourselves. We actually printed some stuff for Sellafield as well, whilst we were in our hub model. But understanding how that worked, what the manufacturing process, if you like, was. We also thought, well, do we want to do in situ printing? And we did. We decided to do both of these because we wanted to understand what the ownership issue was around having robots actually available, a fleet of robots. What happens if we turn up on a site, if we turn up on a site, print Monday to Friday, and on the Friday afternoon we pack up that equipment and move on to another site? Can we really, from Friday afternoon, be printing again on the Monday morning on that next site? What is the impact of weather? Can we print at low temperatures? Can we print at high temperatures? What happens if it suddenly comes down with rain? We wanted to understand all of those different elements for the water industry, so we can share that information with yourselves if you were wanting to pick up this technology and do it at your own sites. And what you'll find over the next few months, we'll start publishing more and more information around what our findings have been to really help you take this technology on board and have a think about where you could use it. There's a few things on 3D concrete printing that we certainly learned throughout our period with the robot. We learned that we can't move away from certain things, so the design element will always be there. We're not able to move the design to one side. We have to do those key structural and civil engineering designs. We had to learn a lot about site management and how we move around the site, particularly with the hub model at Wigan. We needed to understand where we were going to put things, where we were going to print things, how soon, how long do we leave those printed items in place before we move them to one side and we're able to print something else. There was a lot of logistics that we needed to think about around the whole hub model. It was a real key piece of learning for us, and Natalie will go into that a little bit more in a little while, but it's it was key for you to understand that if you're going to take up this technology, you just need to understand it's a logistical planning exercise, which fortunately we had some really good help with throughout the project. We printed a lot of things. In the bottom right hand corner there, you can see a picture of a few of the different items that we printed, and we had quite a lot of visitors come to our site. Lots of people, I think it was around 70 people visited us over the 2-week period. Everyone very interested in what we were doing. Again, something else that you just need to think about if you're thinking about a hub model, if you're thinking about taking this particular technology on. Think about how visitors are going to move around your site, how you're going to keep everybody safe, and then making sure that everybody enjoys their visit. The key thing about developing and printing different things is where do you implement them? And I can tell you that we are implementing these things. Some of the things that we've printed at Wigan are due to be implemented. One at Ellesmere Port for our ID walls for United Utilities, and also Scottish Water have some rectangular CSO chamber elements that they're going to put into place on one of their sites as well. So think about what the next steps are for all of these assets that you're printing. Okay, they can't stay at your printer's hub site. They do need to move on. They do need to be utilised. And that was a key element of our project, was to make sure that we operationalised what we printed, making sure that we really did have a use for these items at a later stage. Just finally from me, I wanted to talk a little bit about the power of the 3D plastic printing, because it was a massive surprise to me, to our project team, exactly what capability is available within this field. A few of you will be sat there saying, well, 3D plastic printing has been around for a while. There's hobbyists out there, there's people that have 3D printers in their homes and are doing this all the time, and you'd be absolutely correct to say that there is. But honestly, I didn't realise how big a deal this was before we went to see Alan and the team at PrintCity, and the number of options that are open to us. I'd strongly recommend getting in touch with PrintCity and trying to understand if they can help you with your different aspects that you're looking at within your businesses, because they really do have a whole range of different printers available to you, different materials that they can print in. It's not just plastics there's metals as well. It really did open our eyes to the art of the possible when we went over to PrintCity, just understanding exactly what there was available to us. Strongly recommend getting in touch with them. It's not just the printing; it's their scanning technology and their design capability as well. Really did help us on the route to delivering a successful project. We're around 80% of the way through our project now. So we're closing in on the end of the project. So as I say, more and more information will become available to you. I hope that you find the next couple of presentations from both Natalie and Alan very helpful, and it persuades you to look a bit deeper into the 3D printing market, understand how it could help you and your business, whether that's in the UK water industry or beyond. So thank you very much for your time. We'll hand over to Natalie now, and she's going to talk to you a bit more about 3D concrete. Thank you very much.
Good morning, everybody. Thank you for joining us on the webinar. I'm Natalie Wadley, and I'm co-founder and CEO of Changemaker 3D. We're delighted to be part of this really groundbreaking project. As a startup that has been working in the water industry now for 3 or 4 years, as you've heard from Lisa and Richard, our journey has come through the UU Innovation Lab, and we've been able to not only find out more about the water industry and where 3D concrete printing can add value, but also where we can knowledge share with our rail and nuclear clients, and we can help to de-risk cross-sector. So for us, this has been the most informative and advanced stage of our journey in the water industry, and being able to share that with yourselves this morning is going to be great in terms of getting some of your feedback and questions as we go through as well. So I think we've heard really from Lisa and Richard that the water industry needs to do something different. It needs to go above and beyond the traditional delivery method to ensure that AMP8 can be fully delivered. And for us, we want to be part of that solution as an integrator of 3D concrete printing, being able to work with our 3D print supply chain partners like Cyber Construction, in this case, in this project, and making sure that we bring the technology from innovation into real world application. That's through design and through the print process. That's where we're driving through that value. And you can see there on the screen what Printfrastructure actually means. So it's about, first of all, identifying the assets and then doing the design work that is compliant with water regulation, that does go through the technology sort of rigor and testing and validation that we've been able to go through in phase 1 and then in this project as well. Really making sure that both the material and the print process leave us with a product that's compliant. And then we're able to innovate with the range of materials. So whether it's the Cyber water, whether it's adding graphene, we've been able to do innovation around the material for the benefit of the water industry as well. And then moving that through into integration. So what does that mean? Well, you've heard from Richard that there's different ways that we can operate with 3D concrete printing. Is it on-site in a Printfrastructure hub? Is it off-site? Where is it in situ? There's 3 delivery models. Each are tailored per site, and each will have its own criteria of benefit when you're considering which is the best for your programme. We know that within a print hub we can have almost like an on-site manufacturing process, but there does need to be value in that. You're not going to turn up for sort of one manhole ring to do that. It's going to be integrated into a larger programme. Equally, being able to print something in situ and take the robot to the final point that the item is, that the product is being printed, that can unlock value as well in a programme. So that integration of the print and the process is where a lot of the planning and the design, sort of the first principles approach that we take, that really gets embedded in that stage. And then we look at actually installing and as we go forward, maintaining and monitoring those assets as well. And all within this, wrapping around it a skills framework, which we're developing in collaboration with industry to take out into 2025, because we see that these skills are very much part of the future for not just the water industry, but construction as a whole. And we see it very much as part of our role to embed that social value into everything that we're doing. So you've heard from all of us this morning that this is a UK first. It was the first opportunity for us to get out onto a water site and to be able to set up our print hub there. We had support from Costain within the enabling works and within some of the facilitation of getting us onto site as well, so that we could also work with some of the framework partners for UU. We've done an awful lot. We've done far more than we thought we could when we set out. We've really pushed ourselves and all the partners to deliver value and learning within this project. So what does that look like? Well, we've designed 5 products, and I'll tell you a little bit more about those as we go through. We also designed 12 variations of base slab. They all had important design roles, not just for the structural performance, but also the way that we install and the way that the product then integrates with the traditional items around it as well. We've demonstrated that we can go from a lorry to printing in 1.5 hours. We had our delivery partners, Cyber Construction, on site with us throughout the programme, and they brought their expertise in at that point to demonstrate how we need to take on this technology as Changemaker 3D as we go forward when we scale up and own our own printers. They showed us how we can optimise deploying the technology out into print hubs up and down the water programmes. So that was impressive. That was fantastic to see that we can have a print capability turn up on site and within an hour and a half you're plugged into water and power, and you're actually doing your first test print. That enabled us to print 23 products in the hub. We had a program, we had a manufacturing program, we had a schedule each day. I wouldn't say every day went smoothly. We had, teething problems around the edges with access to power and just different things that you'd expect as you go through anything of this scale for the first time. But thankfully, the print itself was not the issue, and we were able to make sure that we caught up on our schedule, and we were able to print across an 8-hour shift. And we were able to understand where we could optimise the production process as well, and the way in which you want to configure the layout of the print hub. All of these things really helping us to inform the industry when we go forward about how to bring the technology to site and what types of products in what ways. And one of the things that we took from those 2 weeks in Wigan particularly is, what would happen if you had a night shift, for example. The robot isn't particularly loud, so it does potentially allow for increase in productivity across a night shift. So these are the types of things we were able to discuss as a project team. We were then, as Richard's mentioned, we were able to take the robot to a wastewater works in Weavrum, and we were able to print the distribution chamber completely in situ. So all of that activity culminated in over 4,800 printed layers being laid down over those 3 weeks, a combination of over 30 hours of printing, and we were able to support 3 customers, so Scottish Water and United Utilities and a cross-sector partner, Sellafield, as well, in actually printing products for them that are going to go out into the programme. You've seen some of these images just now on the slides, but that really just highlights to you the 2 approaches we had. Being able to go through sort of a more weatherproofed print hub on site with a relatively small footprint. We were able to show that you can get about between sort of 3 and 5 products through an 8-hour shift within that print hub. It does need, support around it, forklifts, general labour. There is a whole production team that goes into it, but in terms of the print itself, you have a print supervisor, a print technician, and somebody running the mixing system, which when we go forward and we own the printer ourselves, we can have a silo, which helps with saving time on labour as well. But for the purposes of the print hub there are essentially 3 people focused on the print activity. And then you can see how we've got some blue skies in the northwest, which I think we were really fortunate to get back in the summer. And we were able to show the printer out doing its thing in situ, which for us again was a first and really pushed the boundaries of how we manage that workflow in situ. What are the benefits? What are the space constraints? What are the power resources we need there? How quickly can we deploy? And we were, again, we took the learning. There were some areas that we know we can speed up on around transport, loading, unloading. But actually, when you get the robot into position, it can be really consistent in the fact that it can print the design that it's been programmed to. And there's a little bit there about the particular Cybe robot. It's a mobile robot which again for us has proven very, very agile and flexible, both on site and off site, and in different sectors where we've worked with HS2 as well. So understanding that this is something that can go across multiple live sites. It is very fast in its inability to be set up and print. So you're looking at speeds of about 0.5 metre a second, with the material setting in about 3 minutes from the point of mixing to the point of extruding. So it really does, the speed is something that everybody, whether they're in person or watching for the first time on video, it really strikes them that they can stand with us in a print hub for an hour and they're able to see a CSO chamber or an IED wall or a manhole ring be produced in front of them. There's a little snapshot here of the material science. I know this is an area we end up having a lot of good debate on. So if you have questions about it, feel free to put them in the chat and we can look to answer those. But essentially, it's a mortar that we've used, and you can see there some of the performances and also some of the groups that it is it's defined under. But we typically design for sort of a C30 lower carbon properties, and we've been able to demonstrate with cube testing and with on-site testing that we're consistently overachieving those performances in terms of strength. So really the challenge that we wanted to try and bring together from a design perspective was firstly to reduce carbon, and to go about that through really focusing on the benefits of the free form of 3D concrete printing. As you can see in those images, you really can design differently. You fundamentally think differently from the beginning about the way the product is constructed. And also with the speed and efficiency of the robot, we've then got productivity gains that we can start to layer up on that overall value add for the technology. You can see there the circular CSO. So when we talked to Scottish Water and UU, we really wanted to understand what some of the sort of 4 or 5 key products could be for AMP8. CSOs I know are very front and centre for a lot of the water companies, and UU and Scottish Water are no different. So for us being able to show something standardised in a circular format was something that we felt would add value. And you can see there that we've relied on the material, the 3D printed material first and foremost, and then we've reinforced it very specifically where it needs to be. So we've shown confidence in the material. You can see here we've talked about the IED walls, which are again very topical at the moment, looking at ways to support the sewage works that the water companies have in place at the moment. And there is a large programme for IED walls that is being developed. It's been developed as we've been going through the project. And for us, we wanted to show something that really played to the strengths of the 3D printing. And you can see the arched wall there, which I think we'd all agree we wouldn't easily get in a standard or traditional method. In fact, the traditional alternative could be something like a legato block. And so we were able to print these walls with the design strengths for a permanent structure that would allow for some fairly strong water forces going onto it, and that it had to hold containment for 8 days. So that was our design brief. You may be able to see on the screen there that I've just shown you a snapshot of some of the cube tests at 7 days, just to show you that material is overperforming as per our design expectations. So this is an example where you would have one of those walls compared to maybe sort of 4 to 6 legato blocks that would have to be installed and grouted on site. So we're taking steps out of the installation process as well by just having one wall to deal with rather than, between 4 and 6. And these walls are also showing good signs in terms of carbon reduction. We took on a modular challenge with Scottish Water, that we took some learning from our HS2 walls. They were also modular retaining walls, but we took this forward into a rectangular CSO. So it's the largest product we've designed, and arguably sort of the most complex in terms of modular and putting it back together. And you can see through the file there that we've been able to configure walls, again, in a shape that you wouldn't do traditionally, but can be done very efficiently with the concrete printing. And again, placing the material exactly where it's needed. So we're trying to reduce waste, reduce over engineering, and just be very efficient with the material application in the first place. We've taken an awful lot of learning from these walls. I think we probably all agree that we will evolve the design for the next iteration and evolve the way that we would go about installing as well. But I think for the purpose of what we wanted to get out of this particular stage of the project, it's given us an awful lot of insight into how we would print something that's ultimately going to go below ground. So again, thinking about the above and below ground challenges, we've taken all of that on into the project as well. You will have seen on the previous picture about the in situ printed distribution chamber, and you can see here, this is the design that we collectively worked on within the project. We wanted to show something slightly different in sort of a more oval shape. And also to show that you can 3D print the internal dividers as well. So this was printed as one structure. This actually took inspiration from the original water distribution chamber that we printed, where we were also able to print that as one entire structure. So again, saving time, taking steps out of the process, in this case reducing the need for people to go back into a chamber. And you can see there that we put a ring beam around the outside. So just thinking about where some of the forces are on the chamber and being very specific with where we put the material. This took about 2.5 hours to actually print on site. It takes about 20 minutes, 20 to half an hour to sort of get the printer going and do the dry run, what we call a dry run, where the printer calibrates its route, and that's where the print team are checking for doing their quality checks, making sure that where the nozzle on the robot is placed is as per the design. So there's a lot of quality assurance that happens even before the print starts, and then throughout the print process as well. There's monitoring of humidity, temperature of the material. If the material does get quite warm because of the accelerated curing time, so you may see on some of our videos that there's sort of an element of cooling with water. So all of that process is happening all the time around the print, and then at the end of the print we take the cube samples before and at the end, and that's when we're able to get that data through Soccertech there to show you the performance. We were also given the challenge to do a manhole ring, which at the time, if I'm honest, it was almost just a sort of an add-on. We thought, okay, we'll look at manhole rings. We weren't necessarily sort of anticipating there'd be value or lots of data around it, just that we felt that if there was a supply chain issue with manhole rings, we wanted to be able to support the supply chain with quick access to a very standard, regularly used product. But actually, in going through the manhole process, we learned that there are benefits to be gained through concrete printing, both in the speed at which we can support the supply chain. These manhole rings are printed within about an hour and 15, and can be, deployable within 3 to 5 days, but also comparable on sort of cost and carbon as well. So this was actually one of the products that sort of took us all a bit by surprise, that yes, it's very simple, but it's very standardized, and it's something that the technology can help to keep the supply chain moving when we have large volumes of orders that inevitably are going to come through. So you've heard a little bit from us that we also had the opportunity, really thanks to you for enabling Sellafield to come to the Wigan site and to actually see their first 3D concrete printed box printed in person. It was fantastic that we had two large organisations in the northwest of England, large employers in this area, both committed to looking at the technology and supporting the carbon reduction and the innovation around it. They were able to talk from a customer perspective about their respective interest in the technology, and we felt very privileged to be able to enable that joint learning to come together. And just to note that the nuclear box, whilst it does have a nuclear sign on it, is not radioactive. We're all safe in the zone. But again, they wanted to put sort of numbers and images into the facade, something we didn't do on the remainder of the project products. But again, a great example of how you could code a particular box, for example. So again, just, you know, good learning for everybody and good collaboration. We've talked quite a lot about quality and standards, and in itself could be a webinar, but just wanted to have a slide on there to show you the design codes that all of the products were created within. We took the steer from the lead structural engineers from Scottish Water and United Utilities, Duncan and Martin. They both set out the design requirements that we needed to meet for SESWAY, for British standards, and for the technology readiness approvals as well. So a large part of what we've done is really making sure that there's a level of rigour in any of the products that are going out to be deployed into the programme, with an anticipated minimum 50-year life as well, and making sure that because they're all permanent structures, that is taken, you know, very much front and centre for how these products can then be utilised in AMP8. So we did learn an awful lot, as we thought we would, and some of it we've touched on as we've gone through, but just to recap, we definitely learned how to optimise modular design. I think that was, you know, one of the key things we wanted to understand was if we have a larger structure and we want to really be able to get into that modular off-site or on-site offering, how do we approach that from design, but also on install. You know, we're not just focused on the printing of the product, but actually the end-to-end operational delivery. So our interface with the main contractor, our interface with the design teams as well. And I think also the interface with traditional products. So we know that the 3D concrete printed structures are going to have pipework within them. They're going to be part of a larger network. They may even go directly up against a standard concrete structure, a standard description. So what do we need to do there to make sure that the integrity of both of those structures remains as per design? And I think the workflow in the print hub, that was a key point for us as well. You know, 3 to 5 products per day is, I think that's a good place to be from a production point of view. It allows for a steady workflow, but what could we do if we had a larger space? What could we do if we had, you know, 2 robots operating in conjunction with each other, or a night shift? There's all sorts of things there about kind of sort of getting into that lean manufacturing type thinking as well, and blending manufacturing and construction, which the technology allows you to do. I think for me personally, the in situ print was the real wow moment in the project. You know, seeing the robot, you know, just outside of any constraints within the tent and being able to print exactly where the structure is, that really set the bar for where we think we can really start to add some value. And it won't be for every site, but where it is practical, we've proven that it can be done. And I think just having that balance between standardised and bespoke design, we took a lot of opportunity there to look at more complex shapes like the IED wall, the arched walls, but also, as you've seen, a very standard manhole ring. Getting the balance between the two and recognising that where there's a bespoke element, we are seeking to better utilise the shape configuration for the printing, and where it's a standardised design, maybe like a CSO or a manhole ring, that actually we're just utilising as well the speed at which we can produce things. And I think finally, just that value of cross-sector collaboration, bringing together a lot of very passionate people, a lot of very supportive people of what we're doing, both ourselves and our delivery partners, to really break down the remaining barriers, of which they're getting less and less, to adopting this technology and ultimately helping to integrate it into AMP8 and beyond. So I think really that kind of concludes the my section of the webinar. I know we can have question and answer later on, but really just wanted to now pass you over to a video that you'll watch from Alan Dempsey, who was the lead for Work Package 2 on polymer printing. Thank you.
Good morning, everyone. My name's Alan Dempsey and I'm the project manager at PrintCity at Manchester Metropolitan University. We're leading Work Package 2, which is polymer 3D printing. PrintCity is the university's 3D printing hub, and we're a multidisciplinary team of designers and engineers. At PrintCity, we use 3D printing for teaching, research, supporting businesses, and for schools outreach activities. For those of you that are not familiar with 3D printing, it's a manufacturing process where material is deposited one layer at a time until you're left with a three-dimensional object or part. It's an alternative manufacturing process to subtractive manufacturing methods like milling, cutting, or boring. In my experience, many people perceive polymer 3D printing to produce low quality parts that have got visible layer lines, often used by hobbyists. However, the technology is being used in virtually every sector and is a key component in high value manufacturing. Many people have seen 3D printing online, and for those that have, it's usually fused filament fabrication or filament 3D printing. There are 7 types of 3D printing, dozens of subcategories, enabling thousands of materials to be used. At PrintCity, we've got over 80 3D printers. 9 subcategories of 3D printing technologies were available to the WIP project. The benefit of working with an academic partner on Work Package 2 means that the WIP project had access to a variety of technologies available in PrintCity, as well as the specialist academic knowledge in 3D scanning, 3D design, and 3D printing. At PrintCity, we've worked with hundreds of companies over the last few years to investigate if 3D printing can add value to their business by helping them develop new products, services, and processes. We offer specialist advice to identify if 3D printing can add value, help select the right technology and material, and manufacture parts for them to test. So although we've got over 80 printers, there's probably 3 technologies that we used more than most, and they were filament, resin, and powder printing technologies. So filament printers, as you can see on the left, were used for prototyping most of the parts for form and fit. We use this technology to rapidly prototype most of the parts before printing the final version, often in a different process. However, some of the parts were printed using filament printers, the final parts. The technology itself is cheap to buy, it's cheap to run, and it allows us to use filaments that are produced from a recycled source. There are a wide range of materials available for filament printing, as you can see some on the screen. In the middle, we've got resin printing. The image you can see here is a technology called stereolithography. The resin is a photopolymer that's cured by a UV laser. The process is more accurate than filament 3D printing, but the materials are generally more expensive and the process is slower. There are a wide variety of resins available, including tough resins, engineering resins, and flexible. Some of the final parts produced on the stereolithography printer included some of the parts for the labs. The final image on the right is 3D powder printing, and the technology is called selective laser sintering. It fuses polymer powders together with a laser, one layer at a time. The technology is used to produce high precision parts with complex geometries. There are less materials available with this technology, but we can print in both rigid and flexible materials. So the first and one of the most comprehensive tasks in Work Package 2 was to identify suitable parts to design and make. It was really important to select parts that would benefit from utilising polymer 3D printing. Essentially, we're trying to answer a number of questions to select the most impactful parts to design and make. The part selection process happened in 4 stages. In the first stage, we conducted a series of online workshops with key operational teams, outlining what polymer 3D printing is, what materials are available, and why it could and should be used. We then asked the stakeholders to identify what parts we could focus on within their operations. Over 50 parts were discussed and reviewed during this workshop. In the second stage, we invited some of the operational teams into PrintCity to show them the technology and some of the 3D printed samples that we have available. This gave them the opportunity to review previous samples and look at the benefits and limitations of each technology. One of the benefits from visiting PrintCity was that the users could see some of the limitations, some of the size limitations, and discount some of the parts that they were thinking of because they were just too big for polymer 3D printing with the equipment available. Various teams visited PrintCity over a number of weeks to discuss their activities, what those parts do, what environment they operate in, how many they would typically need, which gave us the opportunity to have an informal consultation about the individual parts and their suitability for 3D printing. The third stage involved the PrintCity team visiting various wastewater treatment sites to identify and discuss the benefits of polymer 3D printing. Myself and our technical specialist, Nick Hurst, visited a number of United Utilities wastewater sites and labs at both United Utilities and Scottish Water. We met with the site teams, we walked through the various processes and investigated the opportunities and the benefits for polymer 3D printing for a variety of parts. After the 3 stages were complete, the project team reviewed all the identified parts, scoring them on a matrix that looked at the printability, materials, volume needed, lead times of the traditional parts and suppliers, the impact of using polymer 3D printing, and opportunities to enhance the design of those parts, to name but a few. And once we'd selected those parts, we moved over to the implementation phase. We worked with the stakeholders to design and manufacture those parts. The first stage in polymer 3D printing, in the polymer 3D printing workflow, is to create a 3D model of the part. For work package 2, we did this in a couple of ways for each part. In some cases, 3D scanners were used to capture the data or to scan the environment that those parts need to fit into. We've got a large range of 3D scanners available in PrintCity, both structured light and laser-based scanning. But not all of the parts needed to be scanned. Some of the simpler geometries were just measured and then designed from scratch in computer-aided design software to produce a 3D model. Once we had a 3D model, we sliced it in the 3D printing software. This produces instructions for the 3D printer to follow. And finally, we printed the part. The printed parts were given to the stakeholders for feedback and testing. We tried to be as flexible as possible here by getting feedback by either visiting the wastewater sites, inviting those users back to PrintCity, or having another online meeting. Some of the parts only needed one version to be designed and printed, but others, particularly the more complex parts, needed design changes and a second or third version to be made. We went through an iterative process of feedback, design changes, reprinting and retesting until the users were happy that the 3D printed part was fit for purpose. No parts went through more than 3 design iterations. Finally, once the stakeholders had confirmed that they were happy with the 3D printed parts, they provided us feedback. We then provided the digital files so that those parts could be manufactured on demand. At PrintCity, we don't typically offer a batch 3D printing service. However, there are a number of companies that do, and we can signpost the water companies to those 3D printing bureau services. This means that they can take the CAD files, they know what material, they know what machine to be used, they've got the CAD files, they can work with the bureau services to have them files additively manufactured or 3D printed on demand when they need them in the batch sizes that they need, allowing the water companies to use the technology beyond the project. So on the screen here, you can see 2 of the 3D printed parts that we've developed in Work Package 2. The first is a trough and lid that's been developed for river water quality monitoring as part of the Better Rivers programme. On the top left, you can see the original trough design. We worked with the sensors and instrumentation team and one of the suppliers to redesign the trough and lid using 3D printing. The trough and the lid are part of a wider system where water samples are pumped from the river and an arrangement of sensors take readings to measure the water quality. The lid was designed around the specific arrangement of sensors. The sensors were measured and the lid was designed to fit their unique profile. The trough is intended to contain river water for the sensors to take the readings. The trough design factored in the shape, volume, the depth, how the water would flow through, and had design features such as allowing a tap connector at the bottom so the operational teams could flush the system and remove any solids during routine maintenance. The first version was trialled in workshop conditions for form, fit and function. Feedback from the users led to design modifications, and a second version is currently being trialled at a live site. One of the benefits of using 3D printing for this part was that it enabled the design to be printed within a single day, tested, and for us to receive feedback within a few days. This led to the design changes and an updated version in a short time frame. The ability to design the customized lid and trough means that the system doesn't need to hold or pump as much water, allowing for the reduction in power consumption, and we believe provide carbon savings compared to the original trough design. The modular design means that if one of the sensors is changed, it should only mean that the lid needs to be modified, reducing the time and the waste to manufacture a replacement. I'm really pleased with how this part turned out, and I'm excited to see how the trial progresses. The second part, as you can see on the right, is a wastewater jet head nozzle. The nozzle forms part of a trickle infiltration system at one of the United Utilities sites. The operations team were finding it difficult to source a supplier to manufacture additional nozzles. One of the operational teams, who's a 3D printing enthusiastic, had a go at designing and printing a replacement nozzle. You can see an image of this on the top left. Although the use of 3D printing was correct for this part, the type of 3D printing to use wasn't. The complex shape and the need for a screw thread meant that filament printing wasn't the right technology to use. So we took this 3D printed part, we scanned it, we created a 3D model, as you can see on the top right, and used a different powder printing technology to manufacture another version. The operations team tested this part, and although it worked, they suggested a design improvement that would allow the nozzle to be cleaned more frequently and reduce any blockages. So we took this feedback and produced a second version that you can see on the bottom left. And it has an additional screw thread which would allow the nozzle to be opened and cleaned. The part's currently being trialled at a wastewater site, and the operations team are planning to have a batch of these nozzles 3D printed. The working assumption is that the 3D printed nozzle should last longer than the original version because it can be opened and cleaned when blocked, which wasn't an option with the original part design, showing one of the benefits of 3D printing for this particular part. So there were in excess of around 75 parts identified through the identification stages. Over 20 of these parts were taken forward to the design and prototyping phase, but not all of them were successful. Some of the parts failed during the testing phase. It could have been materials, or it could have been the environment that they were operating in. But 13 of these parts were designed, printed, tested, and we've had positive feedback off the users. Some examples are on the screen. On the bottom left is a CCTV camera skid plate. Feedback from version 1 led us to do an oversized camera collar. The working assumption is that we've got a bigger camera collar which wears over time, and having more material would give that part a longer life. In the middle, one of the parts you can see on the right hand side in the middle is a seal driving tool for some of the United Utilities pump maintenance teams. The tools allows the teams to replace the bearings in the pumps much more efficiently. We've produced a number of these in different sizes relatively quickly for those maintenance teams to use on a variety of pumps that they maintain. On the top right under rivers, you can see a strainer that we designed to complement the system with the trough and the lid. This strainer draws water from the river as part of the River Water Quality Monitoring Project. So we worked with the sensors and instrumentation team and were able to redesign a bespoke strainer from scratch with a view to reduce the ragging or the blockages in the strainer, reducing the frequency of the maintenance visits. Finally, there were a large number of parts designed for the laboratories. Some of the examples are on the screen, including on the left, a bespoke bottle holder for Scottish Water, a suspended drying rack for United Utilities, and a redesigned ionic shaker. feedback from the lab staff at Scottish Water can be seen here on the screen, but it was positive, and the user said that they couldn't source this particular design, which is what they needed. Again, showing one of the advantages of polymer 3D printing in this particular use case. So, delivering work package 2 wasn't without its challenges. If we were to repeat the project again, I think there would have been merit in adapting the approach to identifying the parts. The stage 1 workshops were good, as it was an efficient way to get a lot of stakeholders together. However, to introduce 3D printing to those with limited or no knowledge, explain the differences in the technology, how the technology could be used for a variety of parts, I think there was too much to take in a single workshop or a series of workshops. I found that both inviting the operations teams into PrintCity and for us to visit the wastewater sites in stage 2 and 3 was a more efficient way of identifying suitable assets to design and make. I think if we were to do the project again, we would likely base a member of our team at the wastewater sites during the testing and feedback stage. I think this would have been a more efficient way to review each part's performance and its function, and would have made the redesign process a little bit more efficient. We could have sped up that iterative process. There were a lot of lessons learned in work package 2. Legacy parts or obsolete and legacy parts, and those parts that have a long lead time, presented some of the best opportunities for polymer 3D printing. Even if the 3D printed part was just used to bridge the gap while a traditional part was sourced, I think that 3D printing can offer a lot of value there. I think that we demonstrated value from users informing the design of the 3D printed parts. In the case of the wastewater jet head nozzle, the trough and the lid, and the CCTV camera skid plate, polymer 3D printing enabled us to take those enhanced designs to improve the durability, the ability to maintain, and the life of some of those parts. I think that the wastewater sector could learn a lot from how other sectors are using the technology in both their prototyping and manufacturing of end-use parts. I think one final observation from me is that we've demonstrated the benefit of using 3D printing in a wide variety of applications in the wastewater sector. We're still getting requests from users for additional parts, predominantly from operations teams that we've engaged with already or designed and made parts for. They've come back to us again and again. Can you design another part for us? Can you make another part for us? Which is really encouraging. And I think that we've only really just scratched the surface on what this technology can do for the wastewater sector. I'd like to thank you for your time this morning. I hope you enjoyed the overview of Work Package 2, and I'll hand back to the project partners. Thank you.
Hello everyone, and thank you Ellen for that pre-recorded video. Ellen is unable to join us for this session today. However, keep popping your questions through into the chat, and the project team from UU will try their best to answer any questions. Otherwise, we will be passing on other more technical questions to Alan, and he will be responding to those, and the questions with answers will be uploaded to the Spring platform in about a week's time. So now we are just going to go into a short 10-minute break, and we will be back from the break at 11:20 to hear more about the project from Lisa and Ian. So thank you, and see you back at 11:20. Hi everyone, and welcome back from the break. Now we will be hearing from Lisa and Ian on the reflections from a water company perspective.
Thanks, Ben. Hi again, everyone. Hi, Ian. Maybe you could just introduce yourself, Ian.
Yep. Good Good morning, everyone. So I'm Ian Watt. I'm Scottish Water's Capital Investment Net Zero Manager. In my role up here in Scotland, I work with all our delivery partners, whether that's our alliance partners, our delivery vehicle 2 and Ops Alliance partners, and also our regional contractors, right from Shetland, right down to the borders of Scotland, on their decarbonisation journeys. My team also supports internally within Scottish Water on net zero, all working towards supporting a flourishing Scotland.
Thanks, Ian, and it's been great to have you as a partner on the project. So Ian and I said we'd spend a little bit of time now just talking about what this means for water companies and reflecting on the progress of the project today. As I said, we're kind of midway through the project. We've not finalised everything yet, and we've got a little bit more printing to do, but just reflecting on where we're at and some learning. So I know I started off at the beginning of the session talking around why we needed this project, but really kind of why it's been important for us is, as I said, we've got that huge capital programme that we're facing into that will kick off in April next year, and actually we've already started work on it because it is so big. We are subject to our final determination in December. We are going to be, in essence, building an AMP, or every kind of what we would have built in 5 years, every year for 5 years. And what we needed was innovations and new techniques to digitalise our construction methods and to really kind of bring in the potential of robots to print assets faster, to help us deliver that programme really quickly, to deliver efficiently, and really key for us is about delivering lower carbon solutions. And I know that's a big aspect of your role at Scottish Water, Ian. So was that the same for you?
Yeah, so obviously a lot of similarities. Scottish Water's a public-owned company, so we're fully funded by public charges. So in the delivery of our services, we need to make sure that we are spending that public money very wisely. As you've outlined, like yourselves, we have more demands for maintenance and new assets as we respond to the climate change and growth demands in Scotland. And we've also got internal initiatives around getting to site in half the time and getting off site in half the time. So we need to be more efficient in our delivery of the capital programme. As you said, we also need to achieve net zero. Here in Scotland, our target is 2040, which is ahead of others. And we know today from the work on the capital programme that steels, concretes, plastics and fuels account for about 90% of that carbon. So the WIP project has actually helped us work on 2 of those materials. We also can't keep doing what we've always done. So the project's given us that opportunity to explore what is new, what else can we do today, as well as looking at what might we need to do tomorrow or in the short-term future, as well as what enablers do we need to put in place for the longer-term future. It also expands our collaboration with new and old partners.
Thanks, Ian. And yeah, I think just kind of that collaboration aspect has been really an exciting part of this project, and not all the kind of Ofwat funded projects that we've been working on. It's really great to be working with other water companies, but also other suppliers that we might not work with before. And we've talked about concrete printing and the capital programme, but for us kind of working with Manchester Metropolitan University and PrintCity on the maintenance side and all of those great parts that Alan was talking about on his session. It's really opened our eyes to how we can use the 3D printing to support us with obsolete assets and kind of thing, for example, the sensor issue is a real challenge for us to deliver something, and the 3D printing really is coming to its own in that space in terms of the polymer printing. Ian, maybe you could talk a little bit about what you've done in the project at Scottish Water and a bit about the rectangular CSO chamber.
Yeah, so I've been the link for Scottish Water in exploring the opportunities for both plastic and concrete, really. As Richard would say, I've joined the weekly drumbeats of the meetings, looking at how we get all the enablers in place, and that's been a real eye-opener to ensure that we got all the opportunities realised. I've had the opportunity to introduce both MMU and Changemaker 3D to Scottish Water and our supply chain partners. Again, just continuing to explore the potential for 3D printing. And I suppose I would say that there is great potential through the project. We've shown, as has been outlined this morning, that we can print not only remotely, but we can print in a hub, but more importantly, that we can actually print on site. So that's been some great learning. I mean, Lisa, what are your thoughts on 3D printing itself and opportunities with the polymer?
Yeah, I think for us, as I said before, we had explored the opportunities for 3D printing in our graduate CEO programme, CEO Challenge programme, and through our innovation lab, through working with Changemaker and kind of looking out into the market and people that were kind of key players in the 3D printing environment. But I think just this project has really kind of enabled us all to come together and say, what's the art of the possible? If we could be really ambitious, where could we go with 3D printing, and how could it fit for our sector, but for other sectors as well? And really being able to kind of utilise the Ofwat innovation competition money to really do that first 3D printing hub. And all the visitors that we were able to bring to that to show them how you could apply this in a real life situation, what the challenges are, but also really what all the opportunities are. It's been a massive benefit for us in terms of running this project. Ian, maybe quickly, I think we've got about 2 minutes left. Maybe something that you could reflect on in terms of kind of what could have gone better for you.
Yeah, I mean, I think Natalie herself outlined earlier on the rectangular CSO, there's maybe some things that we would do differently the next time, particularly around the design. But I've got to say, in the 3D printing of concrete, we have been bold. We've been looking to push the boundaries. And as I would say, if we got everything right first time, then we're not pushing hard enough. So it's been really great to get that learning. And I'm sure once the reports are published, other people in the industry and more widely will get great benefit from the work that we've done and the learnings that we've got. Again, the rectangular CSO is one of our standard products, so we're really pushing the boundaries to try and make that repeatable as well.
Yeah, brilliant. Thanks, Ian. And I think, just as we said before, this is just midpoint in the project. This is the learning as we know it now, isn't it? But there's so much more that we're going to work through as we work through the carbon impact of what we've done, the social value, the commercialisation opportunities. We've got all of these parts of the project that we can come and share at a later date. So thanks very much, Ian, for sharing your perspectives on the project.
Okay, thank you.
Hello, thank you very much, Lisa and Ian, for those insights. I am just going to welcome back again Lisa, Natalie and Richard to the Q&A section of this showcase. Okay, cool. So starting us off with a question for Richard from Mary. Do the materials and process for both concrete and plastic have Bridge 31 approvals?
Great question, Mary. Thank you very much for that. Unfortunately not. at the moment, but probably the next step for us is to start looking at the water side of our business and how we can use these printed technologies. That was a conscious decision within the project. We decided that we really did want to start on wastewater first, okay, to really understand how the technologies could support us. So the big no at this stage, unfortunately.
Cool. Did anyone have anything else to add, or?
No, I think it's just from a kind of ease of the project. It's just easier to start off in the wastewater environment, and we know that we've got some work to do if we wanted to move this, and if the sector wants to move this into a water.
Okay, perfect. Thank you. I've also had this question, but assume this technology is not initially considered for drinking water, wastewater treatment sites, infrastructure in contact with drinking water, but that this may come later with the necessary testing.
Yeah, exactly the same answer as David there. So yeah, thanks again for your question, David. Same answer, I'm afraid. Definitely somewhere where we want to go to, just actually not within the scope of our.
Okay, thank you. Can you place reinforcement in the printed units? This is for Natalie.
You can do, although from a design perspective, we always start with using as least reinforcement as possible, so relying on the properties of the 3D printed material. But where it does need reinforcement, yes, you can. There are a couple of ways in which you can go about doing that.
Okay, cool. And what would you say the benefits are in just relying on the 3D printing in general as opposed to?
So firstly, it's about using material in as little efficiently as possible.
Yeah.
So reducing waste.
Mm-hmm.
And also then we're not just sort of relying on kind of the risk of over engineering and just having one size fits all. I think that's where we can move away from.
And I think for kind of from our perspective and yours as well, Natalie, we're trying to reduce the amount of materials. Steel has a high carbon impact, doesn't it? So anything we can do to reduce the material within the unit.
Yeah. Okay, cool. Thank you. So can you vibrate the printed concrete as with traditional concrete placement processes to avoid voids?
So you wouldn't use that process with the 3D printing itself.
Okay.
It comes out in layers that don't have voids within them, and we've got cross sections to show how the material becomes homogeneous. But you can add poured concrete into a void, so like a standard concrete if we were reinforcing it, for example, and that can be vibrated as normal. It doesn't impact the 3D printed element around it.
Cool. Thank you. So what are some of the advantages to your product over, say, its competitors in the industry?
So I think firstly, our business model as Changemaker 3D is that we're an integrator. So we have access to the market, if you like. We've got delivery partners like we've shown with Sybe, but actually there's a whole range of materials and robots that we can deploy. We're UK based. So we're able to have a local footprint and have local job creation. And I think really being able to have our patented designs as well, that's something that's helped to differentiate us from others in the market.
Amazing. And what did you find from the United Utility side of working with Changemaker 3D?
I think so. You came to the UU Innovation Lab, and we worked together for a number of years within the lab, the incubator program, and another project since, and then into the Ofwat project. I think as a business, Changemaker, the whole ethos of the business and the real kind of drive around social value that you deliver, and we saw that in the printing hub, is just really, really positive. And we really want to kind of look at kind of driving all the additional values within our projects. It's not just about cost, efficiency, carbon, and social value is really important to us, and it's a big part of the Changemaker ethos.
Yeah, anything for you, Richard?
It's just been really nice, straightforward working with Changemaker 3D. So when we've got to sites and so on, it's been nice, straightforward project delivery for us. So there's not been too many mishaps en route. It's never completely straightforward, is it? But the things that happen have been small things that we've had to easily overcome in the door.
Yeah, and I guess nice working with that local kind of team as well, so you can be out in the right time zones, not far away. Perfect. Okay, thank you for that. Also another one for Natalie. Would this always require virgin materials, or could you use a percentage of recycled concrete / raw materials?
Yes, you can. And it's not just about using the recycled material in the print, it's also being able to recycle any print material as well. So it's twofold. So we're looking at the moment at taking some of the material we used as part of this process and looking at whether or not it can go to a recycling plant, and showing that actually it can go through and be broken down and used as aggregate. So there's two parts to that. We can recycle in the material itself and look to recycle the material.
Amazing. Okay, cool. That is great. So again, for Natalie, but if anyone else has anything to add, everyone's interested in concrete printing today. What is the tensile strength of the printed concrete? As we know, concrete is weak in tension.
Yeah. So this is a great area that will require further discussion. I'm happy to have follow-up calls on this, but broadly it has a tensile strength of 4 newtons.
Okay, amazing, perfect. Thank you very much. And what is the asset design life of the structures as well?
So with the particular material we've used, obviously work closely with Cybe on their material specifications, and we designed for a minimum 50-year lifespan.
Okay, wow, that is a really long time as well.
And we have had, so we've got a great team at United Utilities and your structural engineers as well.
Yeah.
That you work with, Natalie. And we've got our specialist structural engineer in our civils team. They've all been working together really to kind of test this and to de-risk it, but to work through all those tricky technical conversations that our civil engineers are going to have around something new and something different and something that's kind of, we've not had a 3D printed asset out there for 50 years to say it's there, but we're doing all the right testing to ensure that we're feeling confident about that.
I would just add as well that with the benefit of the HS2 project, they funded a work package of testing the BRE group. They're one of, I think they're the largest research testing institute for the UK, maybe even in Europe actually. So we got a lot of test data about performance, independently verified, that we're able to then bring into this project.
Great, and I guess that's super important as well for projects going forward later in the sector.
Absolutely.
Yeah.
And that was one of the key elements of our project, was just to make sure we did really have that background data, that background testing information, so we can use it going forward.
Yeah.
Otherwise, we'll just get the same questions.
Yeah.
Over again. I mean, if we're going to get into the mainstream project delivery into our capital programs of this across the water industry, we need to know the answers to those questions.
Yeah.
Really key that we pass through kind of that quality gateway.
Yeah, for sure. And it sounds like lots of rigorous testing was obviously done for this project as well. Amazing. Perfect. So on to, where does Ofwat actually get money from to fund the grants and the management of the scheme?
Yeah, so I've talked about the Ofwat competition before, so I'm happy to answer that one. So all the money essentially comes from our customer bills. So there has been, I think it's about £1.50 on every customer in England and Wales that have contributed to the fund. And so we have to be really careful about how we spend that and make sure we're spending it on the right things and things that haven't been tested before and things that are true innovations that will really drive benefit for our customers. And Ofwat really put us through our paces in the application process in bidding for these projects to make sure that that is the case.
Perfect. Okay, cool. Thank you for that insight. Another one is, have you in the project also tested making big infrastructures like manholes and CSOs made in PE and not only mortar / concrete?
Okay, so not in this project.
Okay.
Okay, that's John. So thank you, John. Yeah, no, not in this project, unfortunately. We've stayed, the infrastructure elements have been done in concrete. Okay, in mortar, but we've used for 3D concrete printing. That's not to say we can't look at it in the future, and I think it's certainly something we should put on the list of things we'd like to achieve later on. But just for this project, we stayed for those particular elements. Okay,
perfect. Thank you, Richard. Okay, coming on to some questions that we were sent in previously. How do you ensure parts conform to any necessary regulations and standards?
So we've printed several different parts. This is more about plastics, I think, but it's a work in progress. Okay, like everything in innovation, it's a case of just trying it, seeing if it works, and see if it but I suppose provides the function of the original part. So that's what we're trying to do within this particular project. So if it achieves the same standards, that's great, okay, from a physical use point of view. And as you've heard from Natalie, obviously we've compared the mortars or mortar cubes to the different concrete standards as well, and done extensive laboratory testing on those. So it's about comparing to what you would normally use within the industry.
Okay, perfect, thank you. And maybe another question for you, Richard. Lauren asked, what is the ROI on a project like this?
Oh, what a great question.
We all want to know.
Yeah, that's great. Absolutely. So return on investment on a project like this can generally be rather fast, Lauren, particularly when we're talking about the 3D plastics area. Okay, and we've been printing elements within that work stream that we can use we can print straight away, so we don't have to wait for lengthy periods for delivery of items, or if it's something that we want to bespoke design item that we want to have quite clearly detailed to how we want to use it, we can do that very quickly indeed and print straight away and be able to use it the day after. So it's absolutely brilliant story from a return on investment, just due to the time scales that we can really shrink down to within the plastics printing side.
Yeah, and I think with kind of both of the work packages, the polymers and the concrete, we are working through all the commercial understanding, following kind of doing the actual prints now. So that some of that information will be to come, kind of what's the benefit in terms of cost saving, time saving, all of that. We'll publish that as we publish the results later.
Oh, thank you very much. That's literally just like having a personal shop on site.
It very much is. We understand quickly we can do these things. Yeah, honestly, I think I said it in my presentation earlier. When we look at 3D plastics, sorry, Natalie, we're just going to say, it really did, I think, shock us how big a deal this could be for the water industry, but all the different facets of what we could be doing with different types of plastics, with the different machines and approaches available to us. It opens up a whole new world.
For sure, and I can imagine, and speed up the process, just expedite it.
And I think really important for us, like return on investment's good, but a whole kind of big aspect of this project was around carbon. So we're getting some really fantastic numbers in terms of carbon emissions reduction. We thought there was some there, but actually we're seeing it in places that we kind of hadn't really expected to see it before. The IED walls, for example, and Richard will know the numbers better than me, but we have been exploring different ways different options for retaining walls for the Industrial Emissions Directive programme. It's a massive programme. We've got to do lots of bundling of digesters across the water sector, and the IED wall design is beautiful, and it's lovely, and it's been really fast to print, and that's great, but it's lower cost, and it's helping us with the supply chain issue, but the numbers on carbon are really impressive, aren't they?
You're wrong, because I can't remember. But I want to say, yeah, it's a beautiful design, but it's a beautiful design with a purpose as well. The curves on the design are a structural element of those walls. So and that's what helps, going back to the question about reinforcement. The actual shape, the design shape, is what is helping us not use reinforcement within that particular design, the ID walls, which is a great outcome for ourselves. It's a great outcome for the carbon picture as well. But I'm going to go back to plastics just quickly and just say the carbon that we save on the plastics printing is immense. I think one of the examples we've got is 80% reduction in carbon for one of the elements of it. We printed in plastic.
Jacobs have been helping us with the social value assessment, the life cycle assessment, and the commercialisation, which will publish all of that information. But yeah, Jacobs have been great pulling all that information.
Yeah, for sure, and it's great to see such positive numbers. I mean, 80% reduction is absolutely massive. Yeah,
and the independence of it as well. I think for us, this is the first opportunity we've had as a startup to have an independent organisation like Jacobs really lift the lid on, all of those aspects. So it's not just us coming in and saying, look, this is what we think, this is what we believe. We've now actually got that coming into the industry and saying, yeah, we've checked your numbers, we've compared it to baselines in the industry where we can. So that's really important, not just from our perspective as a company, but actually for the companies that are on the call and that are going to be following up on it to actually see where the value is for 3D print generally. You know,
Of course, yeah, no, that's really valuable insight, and yeah, super important to have that sort of verification as well. Cool. So another audience question that has come through: are the printed structures susceptible to failures that non-traditional materials aren't, due to the anisotropic properties of the final part given the manufacturing process? Anyone?
I don't even understand that question. Just to be quite honest, failures of non-traditional materials aren't due to the. But can we answer Sam another day on that one?
Yes,
So
we can.
We can get back to you, Sam. Apologies
Come back
for
a little
that.
bit in the chat, but yeah, kind of really
happy to answer it.
I don't think that we need to just get a little bit more technical support with that. So.
But all unanswered questions will be posted on the Spring platform, so we'll buy some time to come up with a very good answer.
Wonderful. Apologies again, Sam.
No problem. So how affordable are the printers?
Oh, right. So this is from a plastics point of view, you've got a range. So you can range in size. Some printers are less than £1,000, okay, as an entry level printer, but you can go up to £10,000 plus to get really detailed 3D plastic printing machines. So, but there's a full range of printers. Right. So it's you can. There's a wide range of printers.
So I think that the thing to think about is can you access that service from someone else, or is it kind of the business case there? If you're going to be printing something repeatedly, then you probably need your own printer, and yeah, definitely seems to be the case to do that in the plastic.
Well, just on the plastic side, just as an example. So we have some water nozzles that we printed for our wastewater operations business, and what we've ended up doing, but in that respect, is going not to PrintCity, but going out to a large scale printing supplier or provider. Okay, with that design. But the great thing to understand is once you've got the CAD design, okay, once you've got that data signature, if you like, for what you're wanting to print, then it's available to everybody to go out and go to large scale printing. So we're going to be printing probably a few thousand of those particular water nozzles, which will also have an extended life because of the different material that we're using to process.
Okay, cool.
And extending the life of our old assets as well.
Oh,
We would have
yes, indeed.
have that obsolete parts.
Sorry.
that's right. I was just going to say, in terms of the pricing of robots on the concrete side, it is significantly more than plastics. Somewhere between sort of 300,000 up to £1 million, £1.5 million for some of the larger gantry machines. So you do need, depends on which end of the scale you're looking at. That might be a lot of money, it might not be. From our perspective, it is a lot of money, and you need to therefore have the pipeline and the orders to kind of meet the justification for owning the robots. But if you're a large water company that can unlock value in that, then the return on investment justifies it.
And how do you kind of work with organisations to realise that like cost benefit of installing one of these robots? If you do that at all, like, is there any testing that you do in terms of like how many things need to be printed?
It depends on the delivery model. Like if you're a water company going out to your supply chain, then it's a supply chain discussion with a 3D print company, as or any other. If it's something that you want the water company or the contractor wants to do in-house, then they need to run their own numbers. So there'll be two cost points depending on the delivery model.
Okay, cool.
Another model that you can look at is, we talked about the hub model earlier, and that hub could be in a central location with several different companies. Okay, so you could actually share. So it's just in the Northwest, you heard us talk earlier about what we printed for United Utilities, Scottish Water and Sellafield. So if I was in a central hub, we could print for all three organisations on our basis, and then we print it out to the appropriate sites.
For sure. And I guess
so there are a few different models that you can look at to make this most suitable for you.
And you have that kind of cost sharing option as well, I suppose. Cool. Okay, thank you. Another audience question from John. Are the utilities planning to scale up this and implement 3D into daily operations, or will it stop with the innovation project?
not to stop with the innovation project. That's what we always like to say, John. Okay, we're always looking for how we realise benefits, okay, across whether it's a capital programme or our operational base. I mentioned even the laboratories earlier on. We've been working with laboratories here at UU and with Scottish Water to understand how 3D printing can support them. So the story doesn't stop here. John, we absolutely need to look at how we roll this out and support the delivery of our AMP programme across the water industry. I can't stress enough how this isn't a United Utilities project. We are the lead organisation for a UK water industry-wide project. Okay, so we really do need to share the information we've learned from this particular programme and enable others to realise the benefits.
Yeah, for sure. And I think I mentioned when I opened up the session, we are, as an engineering innovation team, we're positioned with our capital programme team as well. And that is our role as a team, isn't it? We're influencing take-up of innovation in the capital programme. It can't stop with the innovation project because actually the things we've printed are things that we've talked to the capital programme about and they need. And we're just already kind of working so that IED will get deployed in a live environment in the Q1 next year.
Next year, the plan is to go in January, February time to Ellesmere Port. Where's what's works, but
So we weren't just printing things for fun, as we said. We printed things with real uses, and we're ready to go and deploy these now. And as Ian talked about before, Ian deploying the rectangular CSO in Scottish Water as well.
Yeah, absolutely. And just to touch on something else, not just aside to the concrete printed stuff, with our operations teams, we've printed a couple of items within 3D plastics which are physically being used on our sites now. So they're actually in place. We are assessing their efficiency and how we're using them. So things like the water nozzles that I mentioned are physically in place now. We'll be able to report that to all of you, just let you know how that goes and whether that could be a suitable solution.
So yeah, we're innovating in the live environment already. There's no question that we're not using these solutions.
Cool. Okay, I know you said that you weren't printing for fun, so
I don't like to print. It's really interesting watching the printer, and we've been over to PrintCity and watched all the printers there, and the things that they can do with printers is amazing, and kind of stepping into the fashion world and everything.
Yeah.
Kind of the art of the possible, but standing in the print hub in Wigan, I think we all had a little moment of, wow, this is really happening.
Yeah.
But God, it's cool as well. Like
For
watching
sure.
a robot print an asset in an hour, you could bring a visitor to that, they can see it. You could bring an asset owner, an operations team down, they could see their asset being printed within an hour. So it's fun.
yeah.
Really relaxing. Yeah, it's very relaxing. Yeah, absolutely.
Sounds like I need to be in
Sorry, printer for Christmas.
Yeah.
Printer for Christmas.
That's on my list. It's on my list. I'll put that on my list every Christmas. Sure. Cool. So how did you kind of decide which parts were most impactful to print?
Right, so this is really conversations that we've had with our colleagues in
Yeah.
capital delivery within our operations team. So speaking from the PrintCity side of things again, we actually had themselves go into the laboratories, the United Utilities and the Scottish Water, talk to the laboratory staff, make sure they understood the key things that they were looking to improve on and then understand where they could help. We went to Ellesmere Port again with MMU and had them actually positioned on site with their scanning equipment to help them and working with our operations team so that they could get exactly what our operations team were looking for from the plastics side of things. With regards to concrete, Natalie might want to add to this, but we've sat down with different delivery partners within the United Utilities to try and understand what they use the most of. Okay, so one of the examples is what Natalie mentioned earlier in her presentation about the concrete rings. Okay, so we went out to, I think it was Costain, wasn't it? Asked them for their advice, exactly on what's their favourite size of concrete ring. Essentially, how many do they buy? Okay, in an average year, and that gave us the idea for what size we should print, because we saw that as the key area where we could help.
And I think, as you said earlier on as well, the understanding of that from the point at which we applied for the fund to the point at which we actually started to look at design, a period of time had gone on, the unpaid development had gone on as well, and we gone from purely thinking about something quite bespoke, maybe in situ, to actually being able to blend something that can help the supply chain quick call off as well. And I think that was something that really informed. And then with Scottish Water coming on board and saying, well, can we do something larger? That was a great challenge about, well, can we then do modular?
Yeah.
So we ended up with, I think, you know, the three, can we do something in situ, something modular, and something that could just be rinse and repeat as well. So they were we came at this from the problems that the water industry are trying to solve, not here's a piece of tech and where can we apply it. And I think that for me is the most important point.
Yeah.
That we, you know, we're not just taking the tech and saying, oh, it can do this, where does it fit? It's where are the problems, where are the pain points, and then where are the assets that we can help with.
But that's a great thing about technology. So because we can adapt and we can flex to what to the changing environment that we're working in.
Yeah.
So it's really good advantage of the technologies that are out there, 3D printing, that they're able to just change emphasis when we need to along the lines of what different businesses are looking for or different projects need in the web solutions. Very quickly onto our path.
And with minimal cost impact as well, because it might just be, apart from maybe just adjusting some designs or making some tweaks.
Yeah.
You know, we made tweaks on the day in some cases when we were in Wigan.
Yeah.
You know, we calibrated something and it needed an adjustment. The design was adjusted, you know, the team did that within half an hour.
Wow.
You know, so it's you're able to sort of be really dynamic in that live environment as well.
We've also had, kind of on that note, another question come through from Harry, but do the robots need modifying to harden them for regular site use? Obviously at the sites, you know, there's a variety of like temperature and like that might be quite rough and ready. Do they have to be modified at all, or?
Not the robot that we used.
Yeah.
It has a remit. It has a print circumference, 3 meter roughly by 3 meters, and it has temperatures that it can operate within. Broadly, you know, almost down to 0, and it's also been used not by us but by Sabio over in the Emirates, where in Australia, very hot temperatures, lots of dry weather, and you know, sort of dust and conditions like that. So it is quite, again, as to Richard's point, it is very flexible. It doesn't. There are some weatherproofing elements that we would want to look at for the UK particularly, but that's we've got a plan for how we're going to do that.
Nice. I'm just picturing a robot with an umbrella.
Mary Poppins umbrella.
Don't what effective.
I think to say that it's suitable for showery conditions, but when we have to go complete downpour, rain, that's where the problem is. So we do. That's why we went to Weaver, do the in situ print, just to see if we needed to adapt to weather conditions.
Yeah.
We're going to go back there,
Yeah.
okay, in January time, and we're going to print hopefully lower temperatures, okay, so we can understand what the impact is there.
Yeah.
And that is really off a conversation we had with our Scottish Water colleagues when they came to see us. They said, well, this could actually open up the window for construction in Scotland. As the temperatures decrease, maybe we can print things at a lower temperature, so our construction window is wide.
Oh, sorry.
I'm just going to add just on the robustness of the printers themselves. They do sort of function like a digger or forklift. You know, they are robust in their ability to be on site. They're on big crawler tracks. Yes, there's a lot of sort of sensors and things, but they tend to be in the control panel, which is well away from the robot. Robot itself is actually pretty hardy and robust.
And I was actually going to say, linked to that we were talking before, how when we set off the project, we always thought it was in situ bespoke design that was going to kind of really play to the strengths of the robot, but actually the hub model's really shown us that kind of printing repeatable assets in a centralised hub and moving them out to the location might actually be the better way to go, or utilise.
Or a bigger part of it. Yeah.
Cool. Okay, well, I think that is all we have time for today, but thank you so much.
No more questions.
There is no more, but we will pop them on the Spring platform. So send your questions through and we'll pass them on to the presenting team. So thank you, Natalie, Lisa and Richard, and also Ian and Alan who have joined virtually. And also thank you to everyone who took the time out of their day to join us. We hope you found this session valuable. I believe my colleague has popped a link to a poll in the chat about today's session. So please do take a moment to give us some feedback, as we find it extremely valuable. As mentioned at the beginning, we'll be posting a recording of today's session on our Spring platform, along with the case study and Q&A, which should be available within a week's time. So any questions that have been answered during today's event will also upload. So thank you all again for coming, and thank you to our lovely presenting team, and have a great day.
Thank you. Bye.
All right.